Dear students, we are continuing our discussion on Module 6. In the last video lecture, part 4, we have discussed about the reliability. In this video lecture, we are continuing the discussion on reliability but in a system context. So here we are discussing system reliability. So what is a system reliability? Before that, what is a system? A system will be a collection of components or subsystems assembled to perform a specific task. Basically, in a system, there are more number of components are there, more number of subcomponents are there, all together will perform a specific task. So, maybe consider in the case of a television. A television we can consider as a system. In television, we have many components is there, many subsystems are there. A subsystem for picture tube, a subsystem for sound system, a subsystem for maybe for audio, a subsystem for lighting, etc. 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 Each subsystem have n number of components. All these together is working as a television, and we will get the required output. So, in a system, the arrangement of components can be in three ways. In a system, arrangement of components can be in three ways: either series system or parallel, and third one is combined of both series as well as parallel. Series, parallel as well as combined. Why we are discussing about these in reliability? As we know that by studying all this only we can ensure that a system reliability or a reliability of a product. Okay, so what is a series system? What is importance of system reliability before we are discussing about the series system? System reliability depends upon the component reliability and system structure. As we know that in a television, if a single microchip is failure, television is not going to work. So, the all system reliability is dependent upon individual component reliability. So, and also the system structure and also redundancy. These factors are important. One is improve component reliability, improve system structure. Third one is built in redundancy. We will discuss what is redundancy. Okay, by improving system reliability, we have three options. One, improve component reliability, improve system structure, improve redundancy. The first one is what are the different types of systems. The first system is series system. First system is series system. In series system, all components or subsystems are connected in series. A series system fails as long as any of the components fail. As shown in the figure, from input to output, there are four components are there: component 1, component 2, component 3, and component 4. All these four components are connected in series. But if the system will work if all these four components are works, if at least any of the system component will failure. Consider if a component 3 is failure, that is not only the failure of a component 3, it's a failure of entire system. So, how will calculate the system reliability for a system? How will calculate the system reliability if components are connected in series? Consider this example. If each component 1, 2, 3, 4 having a individual reliability of R1, R2, R3 and R4, the system reliability will be the multiplication of R1, R2, R3 and R4 like this. The system reliability will be Px1 into Px2 into Px3 into Px4 into up to Px1, and in the early cases R1 into R2 into R3 into R4. That will be the system reliability when the components are connected in series. Consider a small example. Suppose the system consists of four components. Okay, the first two components having a reliability of 0.9 for a period of 1 year. Other two components are have a reliability of 0.8 for a period of 1 year. And what will be the overall reliability? Two components have reliability of 0.9, two components having a reliability of 0.8 for a period of 1 year. The system reliability will be the multiplication of all these four, basically 0.9 into 0.9 into 0.8 into 0.8. That is a 0.9 all squared into 0.8 all squared. That will be the system reliability. It is clear. We also need to consider the failure rate and mean time to failure and also the reliability factor when if the lambda is the failure rate, if lambda is the failure rate of individual system, as we know that, and lambda I is the failure of individual component, lambda s will be is the sum of lambda I, and MTTF equal to 1 by lambda, as we already discussed in the last section. Reliability will be e raised to minus lambda t, ft will be 1 minus e raised to minus lambda t. We already discussed this in the last video lecture. Consider a small example. For an electronic equipment operated by 4 dry cells, each have 1.5 volt, they are connected in series. The probability of successful operation of each cell is 0.9. So reliability equal to 0.9. What will be the reliability of the power system? 4 are connected in series and reliability is 0.9. The total reliability will be 0.9 into 0.9 into 0.9 into 0.9, that is 0.656. That is about series system. Now we are moving to parallel system. In parallel system, all components must fail in a system fail. Here the components are connected in series, in parallel. Here the components are connected in parallel. As shown in the figure, 3 components 1, 2, 3 are connected in parallel. Usually all 3 components will be same, and as we said, if a system fails, if a component 1 fails, does not mean that the entire system is failed. If the component 1 is failed, the system will work with the help of component 2 and component 3. Here the components are connected in parallel. So what will be the system reliability? System reliability PS will be equal to 1 minus, in bracket, 1 minus P of x all raised to n. PS equal to 1 minus, in bracket, 1 minus P of x, that is the probability of x. As we in terms of reliability of system will be equal to 1 minus 1, in bracket, 1 minus reliability of individual component all raised to n. If you have only 2 components, PA and PA and B, the first equation if n equal to 2, in the equation P of s equal to 1 minus P of x all raised to n. Here if n equal to 2, and we are saying that n equal to 2 and that are A and B, then P of s will be equal to P of A plus P of B minus P of A into P of B. We can by heart that equation. If 2 components are connected in parallel, the reliability of the system will be equal to P of A into P of B minus P of A plus P of A plus P of B minus P of A into P of B. If 2 components are connected in parallel, the system reliability will be P of A plus P of B minus P of A into P of B. Consider an equation, example. Here 3 identical units are connected in parallel, so we can't use the equation P of A plus P of B into minus P of A into P of B. We have to use the equation, the general equation, 1 minus, in bracket, 1 minus P of x all raised to n. Here n equal to 3 and x equal to unit reliability equal to 0.9. So reliability will be equal to 1 minus, in bracket, 1 minus 0.9 all raised to 3, that's equal to 0.999. Okay. One more example. A parallel system composed of 10 components. Here n equal to 10 and P of s equal to 0.95. P of s system reliability is given. Then what is component reliability? Great. Here the system reliability is given We know that P of x 0.95 equal to 1 minus P of x all raised to 10. So P of x will be equal to 0.2581. Hope is clear. Very simple example. We can calculate here the system reliability and number of components are given. We have to calculate the component reliability. So that is parallel system. Third structure, mixed structure. Here the series and parallel structures are connected together for increase the reliability. As shown in the figure, here the component 1 and 2 are connected in series, but component 4 and 5 are connected in parallel, and component 3 is connected to series with a combination of component 4 and 5. So we will get a functioning. Here the both series system as well as parallel system is used in mixed system. This is a very simple example, not very simple. Here many number of components, but both systems are there, both series system as well as parallel system. I have to do one or two examples for solving the problem, how we will find the system reliability for a series system. Look into the first example, look into the figure. We have three components A and B, input, output. A and B are connected in parallel. C is connected to series with a combination of A and B. For solving the system reliability of for a mixed system, we have to start from one point. Here, the A and B are connected in parallel. So we will consider A and B first, which are connected in parallel. How will find the system reliability of A and B together, which is connected in parallel? As we know, if two items are connected in parallel, equation will be P of A plus P of B minus P of A into P of B. So reliability of A and B together, 0.8 plus 0.7 minus 0.8 into 0.7. That's equal to 0.94. We can name it as D. So now the structure will be combination of D and C, which is connected in series. 0.94 and 0.9 connected in series. What will be system reliability? 0.94 into 0.9, that's equal to 0.846. So 0.846 is the system reliability of entire system. Hope it's very simple, but try to solve from one end. Is it clear? Okay. Next example, four components, component A, component B, component C and component D. We need to find the system reliability. So we will, which all components we will consider first? By looking at the figure, which components we will consider first? We will, from the figure, it's clearly we know that we can first consider component B and C together. Both are series. So we can have both are series. What will the system reliability of B and C together, which are connected in series? 0.8 into 0.9, that's equal to 0.72. So we will solve the first step. Now we can name it F. So A, F and D. 0.9, 0.72, 0.7. Look in the second figure. We will solve which one? F and D, which is connected in parallel. F and D, which is connected in parallel. 0.72 plus 0.7 minus 0.72 into 0.7, that's equal to 0.916. We can name it as G. So third figure, 0.9 and 0.916, which is connected in series. System reliability will be equal to 0.9 into 0.916, that is equal to 0.8244. Like this, we can find the system reliability of an item when it is connected to both series as well as parallel. What is the term redundancy? Actually, while we are discussing about the parallel system itself, we have to be clear what is redundancy. If you need to give a definition for redundancy, redundancy is existence of more than one means of performing the required function. As we know that in parallel system, If a component 1 is failure, we, also the system will not be failure, it will be function with the help of other system. So redundant, if a system, we are saying that if a product has high redundancy, we will ensure more than one way of arrangement to ensure if one component is failure, other will work. Usually we can ensure the redundancy by two ways: unit redundancy or system redundancy and component redundancy. First one is unit redundancy, it's also called system level redundancy. Second one is component level redundancy. We can ensure the unit redundancy or a component level redundancy. What is the difference between a unit redundancy and a component level redundancy? Look at this figure. First one, unit redundancy. In unit redundancy, consider actually the system will be having a, in unit redundancy, we will redundant or we will replicate entire system. Okay, actually the arrangement will be as shown in the first figure, A1, B1 in series, but we will ensure A2, B2 in the same way. If A1, B1 will fail, A2, B2 will work. Here we will redundant entire system. But what will happen in the case of component redundancy? Here we will redundant each component. If A1 fails, A2 will work. If B1 fails, B2 will work. Here we are not redundant entire system. Here we will redundant each component. Hope you get the difference between a system redundancy and a component redundancy. System redundancy also called unit redundancy. So in this lecture, we have discussed about the system reliability in detail. Hope is clear. In next lecture, we will continue the discussion on module 6. Thank you.